In this video, we are going to study the topic linear approximation or linearization. Linear approximation is used to approximate the value of a curve at a point close to the point of tangent. Since we are using a straight line tangent graph to approximate the value, that's why this is called linear approximation. So all we need to know is the equation of tangent line, which we are already familiar with. Equation of tangent line is given as at the point x1, y1. This tangent line equation can be rewritten as, so if you remember the tangent line equation, we can easily rewrite it as the linear approximation equation. Y1 is nothing, just the y value at point A. This can be rewritten as f of A plus the slope m represent value of the derivative of the given function at that point. So it's f prime A times x minus x1 is just the point where we need to approximate, or which is the point of contact. So we can see that linear approximation formula is similar to the tangent line equation. The point x1 is just the point of approximation, which is A, and y1 is the value of the function at that point. F dash A represent the slope of the function at that point. Now let us start working on this problem. Use linearization to approximate 1 over 1.99. For these kind of problems, we are given just the value. We don't have any function, we don't have any point of tangent. So that's all we need to observe from the given value. Now this value is similar to the function 1 over x. So for the first step, we identify the function. Here the function is of the form fx equals 1 over x. Then we identify a value a which is closer to the given x value, and in such a way that it's easy to work out f of a and f prime a. Here we see that 1.99 is closer to whole number 2. It's best to choose a as 2. For second step, we find the y value at a. So f of a would be 1 over, and then we find the derivative f prime x. The derivative of 1 over x is 1 times x raised to negative 2 comes negative 1 over x square using the power rule. And then we find the value of this function at, so it's negative 1 over 2 square, which is just negative 1 over 4. For next step, we just write the formula for linear approximation. A value is 2, so we just plug in a as 2. So this is the formula we got for linear approximation. For next step, we just plug in the given value of x. Since it says to approximate 1.99, so we are going to replace x with 1.99. After simplifying it, we get the final answer as 0.5025. This is how we work on linear approximations. For this next problem, we are given a function as well as the point where we need to approximate the value of this function. For the first step, we just find f of a, which is the y value at the given point, f of 8, and it gets simplified. Since 8 can be rewritten as 2 cubed, and these powers get cancelled, and we are left with 1 over 2. So f of 8 gets simplified to 1 over 2, and we get fa equals 1 over 2. For step 2, we find the derivative of the given function. Since this function can be written in terms of exponents as x raised to negative 1/3, because we move the powers to the top so that we are able to apply the power rule. And using the power rule, power negative 1/3 comes in front, and then we find the value of this derivative at the point of approximation. So we find f prime 8. Again we simplified using the same way. 8 can be replaced as 2 cubed, and then those powers get cross cancelled, and we are left with 2 raised to 4, which gets simplified to 1 over 48. So we got the slope as negative 1 over 48. For next step, we just rewrite the formula for linear approximation and plug in the values. So this is the equation we got for linear approximation. Now for next part, we need to approximate this value using the linear approximation we got in the earlier parts. So all we need to do is just plug in the value of x as 9. This is the x value which we need to approximate. We are going to replace x with 9 in the equation we got earlier, and it gets simplified to 1/2 minus 1/48. So this is how we use linear approximation to approximate the x value when we are given a function and we are also given the point of approximation. For this next problem, we are given a composite function which we need to approximate at x equals 4. So initial steps are very similar to the same we did earlier. For step 1, we find the y value at x equals 4. When we plug in x as 4, we got 27, and cube root of 27 is 3. So we got f4 equals 1/3. For the second step, we find the derivative of the function, but before that we need to rewrite this function in terms of exponents, and then we find the derivative using chain rule. First we apply the power rule. Then we find the value of this derivative at x equals 4, which is the point of approximation. So we just replace x with 4 and simplify the function. For next step, we write the equation for approximation. So this is the equation of approximation for the given function at x equals 4. Now this step is different from the earlier problem. To approximate this value, we don't just plug in x as 28. We should not plug in x as 28 because this is not the x value which we need to approximate. Here we were given this function, and when we compare both these functions, we see that 5x plus 7 equals 28. By comparing them, we get the value of x as 4.2. That means we need to approximate the x value at 4.2. So don't plug in x as 28. This is the mistake most students do, that they just plug in x as 28 to approximate. But this is not the x value. To get the x value, we just compare these two expressions and solve it for x. Next, we write the linear approximation equation which we got from the earlier part. And since we need to approximate at 4.2, so we are going to plug in x as 4.2. After simplifying this, we get the value. So this is the approximation at x equals 4.2. For next part, we need to find the error of approximation at x equals 4.2, which is nothing but the difference of actual value minus the estimated value. Actual value at 4.2 is this, which was already given, and estimated value is, which gives us the error equals to 0.000099. So this is the error of approximation. Here is a similar practice problem for you. Please write its answer in the comment box. Thank you.